So I've been working on this project where I'm trying to use a custom wound coil to detect the presence of a metal object, so otherwise known as inductive sensing. And as I was trying to sort of learn about this whole concept, how a coil can sense a metal object, I kind of realized that there really wasn't a lot of practical information available on the internet or YouTube that showed somebody actually doing this setup and testing a coil. There was a lot of theoretical information, but it didn't really help me because I just kind of still felt lost because there wasn't really much out there showing a physical coil and a breadboard and a capacitor and how it all hooks together and what the expected results should be when you hook it up to a signal generator and an oscilloscope. So today I decided to make this quick video just in case somebody else is out there looking for that information and you're maybe still a little bit lost in the theoretical stuff. Here's a really practical example of how to use an oscilloscope to determine the resonant frequency of an LC circuit that is a coil and a capacitor, or an inductor and a capacitor, which can then be used to sense the presence of metal objects through inductive sensing. So we have three components here in front of us. We have our oscilloscope. The oscilloscope is going to be both a signal generator and read in the returned signal. So this is a picoscope or picoscope. They're pretty cheap for what they are, and it just plugs into your computer and you use their free software to both generate the signal and read the signal back in. So yeah, highly recommend getting one of these if you don't already have some sort of oscilloscope. And we have our breadboard here, and there's really not much going on. It's just a single capacitor in parallel with our coil. So I'll draw a little schematic and put it up on the screen here so you could see schematically what's going on, but the breadboard just kind of makes everything easier when I'm switching different coil designs out and I don't have a million wires all over the place. And of course we have our coil. So this is just a custom wound coil. I 3D printed a plastic ring with a little groove in it, and I wrapped it with 25 turns of magnet wire. And you could buy this magnet wire pretty much anywhere. It's fairly inexpensive. So yeah, this happens to be 28 gauge magnet wire, and just get a whole spool of that and you could experiment with winding a bunch of different coils. Just a quick note about selecting a capacitor value. You might be limited in the frequencies you can generate. In my case, I can only generate frequencies between 0 and 100 kilohertz. So I want to make sure that I choose a capacitor that gets me somewhere in that ballpark. So you start by using the top equation, and that's going to estimate the inductance of your coil. And then once you have that, you plug it into the bottom of the equation along with a few different values for the capacitor, and you can kind of see approximately where your resonant frequency is going to be. So if you choose a capacitor that puts your resonant frequency outside of a range of frequencies you're capable of generating with whatever equipment you're using, then you need to adjust that value up or down until you get within that range of frequencies. And typically you want to avoid really, really low frequencies, anywhere from 60 to 100 hertz, because that tends to pick up interference from AC house wiring. And you want to avoid super high frequencies just because they're hard to produce. So I think a typical rule of thumb is like 5 kilohertz to a few megahertz, but yeah, you could kind of look up the specs for whatever equipment you're using and just try to pick a capacitor value that gets you somewhere in the middle of there so that you can easily achieve the resonant frequency. All right, so here we are in the software for the picoscope, and what I have going on here is we have a signal generator that's generating a sine wave, and we could adjust the frequency of that sine wave. And we also have channel A, which is reading the feedback that is coming out of the LC circuit. So what we're going to see is, since an LC circuit has a particular frequency at which it's naturally going to oscillate, as we change this frequency, we're going to see the amplitude increase and decrease as we get closer and farther away from that natural frequency. So you can see as I'm increasing the frequency here, our amplitude of the wave is growing and growing and growing until it's sort of slowing down, and now it looks like I've kind of hit the peak somewhere right around 45 kilohertz, and then it starts getting smaller again as we go above that frequency. So again, I'm just going to pull that right back down until we can kind of determine our peak. And that seems to be our peak right there. So now we're exciting that circuit at its desired natural frequency. And we can see what happens where if I take a metal object like this cup and I set it on top of the coil or move it closer to the coil, it is affecting the magnetic field of that coil, and we could see that in the change in amplitude on the screen, on the oscilloscope. So that change in amplitude is what we can monitor to determine when a metal object is present. So if I put my hand over it, nothing really happens. But when I put this coffee cup over it, it changes that amplitude. It also changes if we were to take something and put it through the middle of the coil. Like this Leatherman, I'll put it through the middle of the coil, and we could see that that amplitude drops because we're affecting the reactance, I suppose, of this coil. So yeah, that's a pretty basic crash course in coil tuning and how you could use it for a practical application like sensing a metal object. It took me almost a whole week to kind of get to this point, and so hopefully you find this video helpful and it helps you get this concept up and running in your own workshop a lot faster than it took me having to comb through all the theory and sort of just figure this out on my own. So enjoy!